We're moving right along in this unit, getting close to the end. We're on section 1.6. The I can statement is I can understand and use set and interval notation. So let's write the word interval right here. And let's talk about what the word interval means, because we're going to be using interval notation. So what is an interval? Stop and think about times where you may have heard that word used. An interval is basically a space. If it's an interval of time, it's a space of time and things like that. So what we're talking about when we talk about an interval is we're talking about some space. Not like outer space, but just like making some space or something like that. So when we've been solving inequalities, we usually get a range of answers. We get a whole bunch of answers that make the inequality true. Remember, that's the whole point of solving an equation or solving an inequality, is finding a number or numbers that make the inequality or the equation true. In fact, when we solve an inequality, most of the time they take up so much space on the number line, this gigantic range, we get an infinite number of solutions. So infinite, an infinite number of solutions. Now, since we can't write them down all the time or write them down individually because that would just take forever, we've got a couple of things in place. Our mathematicians have developed some things that will make this a little bit easier. One of them is called set builder notation, and the other one is called interval notation. And what that allows us to do is it allows us to take this gigantic space, this infinite number of solutions, and allows us to write it down in kind of a compact form. So we're going to look at set builder notation first. And set builder notation looks like this. So the first thing we'll notice is we have to start with this type of bracket and end with this type of bracket. Those are called set brackets. Okay, and then what we put right here, the first thing we put in here is we put the variable. Now most of the time we end up using the variable x, but we'd put the variable right there. And then we've got this vertical bar right here. Remember, I've probably mentioned several times, mathematicians tend to be lazy, but they want to get things right. They don't want to write words over and over again. So this vertical bar means the words such that. That vertical bar takes the place of two words. The words are such that. Okay, and then what we put right here, the end thing right here, is the expression that describes the answers or the solutions. Okay, so there are kind of four parts here. We got to have the set brackets. That's kind of a no-brainer. We put the variable that we're using in the problem, and then we use this vertical bar for the word such that, and then we've got this expression that describes the answer. Sounds more complicated than it is, but we'll take a look at a couple of examples and see how it goes. So remember, a set is a collection or a list of things. So with set builder notation, what it does is it uses set brackets to collect all of those solutions together, to collect that huge range of infinite answers that we were talking about earlier. So this is going to be pretty easy as long as we know how to write inequalities, and I'm hoping we're pretty good at that right now. So here's the deal. We're going to write this compound inequality. Remember, this is written without a word or a symbol, so the word that connects these is and. So we're looking at answers that are bigger than -3 and at the same time less than or equal to +5. So here's how we do this. In set builder notation, it is literally this easy. There are the set brackets, and I'm going to draw a couple set brackets. Mine look horrible, I'll just warn you right now. The variable we're using is x, so I'm going to put an x right here. And then we put the expression that represents the answers. Well, this is the answer, so I'm just going to write the -3, and I'm going to write the 5 right here, and that's it. I'm done with it. Now, I am going to read this so that we can kind of identify all of these points here. So the answers are the set of x's such that -3 is less than x is less than or equal to 5. Or if you wanted to, you could come in here and again read this from the variable x's that are greater than -3 and at the same time less than or equal to 5. So that's how we write it in set builder notation. It takes a little bit more work than doing this. That's why some people don't like it, and I'm going to give you a better alternative in a few minutes. But we do have to know how to work with set builder notation. The graph of this would look like this. So what we're talking about is we've got -3 here. We're going to circle that. We've got 5 here. We're going to circle that. 0, of course, is somewhere about right there. And we're going to fill this in right here, and we're going to shade from here to here. These are all the answers, okay? So this is set builder notation. That's how we'd write it just with an inequality. And this is what the answer looks like if we graph it. Now, I'm going to show you interval notation. And interval notation is awesome because it looks like this. We're basically just going to write down, okay, the answers start at -3. We're going to put a comma, and then they end at 5. We're basically just describing what the interval would look like. And then the only thing that we do next is we need to differentiate between when they're included and when they're not. So this one is not included, so we use a round bracket, and this one is included, so we use a square bracket. So all three of these things mean exactly the same thing. This is a graph of the answers. This is set builder notation using the inequality, and this is an interval notation that represents that space of answers, that infinite number of answers from -3 to 5. Okay, so the reason we like interval notation is because it's really easy. All you have to do is state where the answers start. And when we say start, what we're talking about is we're going to go from left to right. So we always start down here, and we always put the first one, the smallest one that we come to, if you want to think of it that way. We put that one down first, then a comma, and then we put where the answers stop. Okay, so put down where they start, put down where they stop, and of course we put that comma in between, and then all we have to do is do we do round brackets or square brackets, and that depends on whether the endpoints are included. Okay, if they're included, we use a square bracket. If they're not included, we use an open bracket. So we call this a closed bracket, open bracket, round bracket, square bracket, whatever you want to call it, lots of different names. So what I've got here is an example. This is example number 2. It's got 3 different parts, and each one of these 3 problems has 3 different parts. So we're going to write the answer in set builder notation, we're going to graph it, and we're going to write it down in interval notation. And on each one of these, only one of those formats is given to you. So on this one, we've got interval notation. What we don't have is we don't have a graph of it, and we don't have set builder notation. So here's what we're going to do. Let's go from interval notation to a graph of this. So -5 is on the bottom. We're going to circle that. 2 is on the top. We're going to circle that. Notice the square bracket around the -5, so that one is included. Notice the open bracket, the round bracket around the 2, so that one's not. And the interval, the space that this covers, is everything in between, so it looks like that. All right, so now we're going to write this down in set builder notation, and for that we have to have that inequality in here, this expression that represents what the answers are. So the answers are in here. Anything in here is totally okay, and -5 is down here, and 2 is up here. It can equal that. It's got to be bigger than or equal to -5, and it's got to be flat less than the 2. So if you can go from here and just put this right in here, so I'm going to do -5 less than or equal to x less than 2, and then we just put an x. That's it. So these things right here, in fact, I'm actually going to go ahead and erase this just so we can see what we look at for the answer. This is set builder notation. This is a graph of the answer, and this is interval notation. Okay? So looking right here, we've got a graph of this. So for set builder notation, here's what I'm going to do. So I told you I'd draw crappy brackets. They kind of look like that. Maybe I can do better. Let's do this. All right, that's about as good as it gets. So x such that, so we just do x in the bar. And then the answers on this are bigger than, so this is -15. So I'm going to do -15 here. Notice that it's included, and I'm going to write it like that, and then I got to do another bracket. Okay, those look really crappy. Just do your best, and we'll kind of get the idea. All right, so that's what that looks like that. And then interval notation is going to look like this. So again, starting from left to right, we're going to start right here at -15. We put a comma, and then we say where we stop. Well, we don't stop, we continue going forever. So the number, or really the idea that's out at the end there, saying that we go on forever, is an infinity. And we always do round brackets around infinity, okay? Always round infinity, okay? Always round around infinity, all right? Now, this one is included, so we're going to put a square bracket right there, and we're all set to go. So set builder notation, graph, interval notation. Now on this one, we've got set builder notation, which I think is kind of a pain in the butt. That's done for us. So let's go ahead and take a look at how we could graph this. So here is, let's put 0 right here, -1 right here. We're talking about answers that are less than -1, so we're going to shade this direction. Okay, or greater than 2. So we're going to do a 2 about right here, and greater than 2. So that's what that would look like. Now interval notation comes in 2 pieces. There's an interval down here that's part of the answer, and there's an interval up here. So here's what we do. We start way down at the end, so that would be -infinity, and remember, we always do round around infinities. Put a comma, and then they stop at -1, and notice that's not filled in, so we'll put a round bracket, and then they start up again at 2, round bracket there because it's not included, and then it goes all the way to the end, so it goes to +infinity. Now, the word or, remember, is a union. So we're putting these two pieces together. So this is where that symbol that we talked about last time comes in handy. So instead of writing the word or here, we just put kind of that U shape there, and there's the answer. Again, set builder notation, graph of the answer, and then interval notation. Now, as kind of a follow-up, it's really important that not only that you're able to do this, but you can identify, well, what does this actually mean? What are the answers to these inequalities? Or is this in the interval or things like that? So it says, which numbers below are solutions to the inequalities above? Go ahead and circle the answers. So let's take a look at 0. Is 0 a solution to this inequality right here, or is it in that interval? Well, 0 would be about right there, so yes, we're going to go ahead and circle that one. -3 would be in there, so that's an answer. 400 would be way up here on this end, so that one's not. And 2 is right here. Well, 2, we did graph that number, but it's an open circle, so the question here is that shaded? It's not, so that one is not an answer, okay? Let's go for the next one, so look at B up here. Is 0 part of the solution? So let's see. Well, this is why it's important to know your scale and stuff like that. 0 would be up here. I mean, if we're going, this is -15, -14, -10, we get to -1 and 0, so that would be included. -15, is that one included? That is one of the ones that got graphed. It's a closed circle, so that one's included. 400 is way up here, so that would be included. What about -300? -300 would be down here, so that one's not included. Okay, let's take a look at this last one. For example, C. 0, is that included in this interval? It's not, so we're going to cross that one off. -10, yep, -10 would be down here, so that one's included. What about 400? 400 would be way up there. That one would be included. And how about 2? Well, 2, we run into the same thing that we did here. It is kind of the end point, but because it's not shaded in, because it's not included, because the answers are strictly greater than 2, we cross that one off. That one's not part of the solution. Okay, now, question for you. You may have caught on to my bias here, but what type of notation do you think mathematicians like? Do you think they like set notation, set builder notation, or do you think they like interval notation? Well, I hope I've made it clear. We really like interval notation. It's just easier to understand. It's not as wordy or anything. You can almost go directly from the interval right to the graph and vice versa because everything's in order. Again, this whole idea from left to right is a big deal. So please make sure that when you're writing things in interval notation, you start on the left and you go to the right. Now, we're going to take a look at problem number 8 from the assignment, and then we're going to come back and we're going to do the self-assessment, and we're going to look at a couple of interesting problems here as a thought experiment. So let's take a look at number 8. So I'm going to flip over here. We're going to come down here to number 8, and let's say, make sure we have this clear. We've got a graph right here. This next one is going to be set builder notation, interval notation, and then a sample solution. These are going to vary. So I'm going to write answers will vary. Lots of different answers that you can give here because remember, when we have a range of answers, when we have an interval, there's an infinite number of answers in that interval. So I'm going to slide down here. And let's take a look at number 8. So we're going to go ahead and start writing down the answers. So here you'll see my set brackets again. Let's see. So they're going to look something like that. And then X such that. Now, I will warn you on this right here. Some of these are big, some of these are small. They're scaled differently. So on this one right here, that number right there is -5. It's right in between -6 and -4, so that's going to be -5. So I'm going to say that those X's are less than -5, so that takes care of this guy right here. Let's use the word or, and then over here, right in between 8 and 9, so the answers on this one are bigger than 9. So I'm going to say 9's right here, and those the X's are bigger. Now, that is certainly not the only way to write those. If you wanted to flip those around so the X's come first, or whatever you want to do, that would be totally okay. Remember, when it comes in two different pieces, you have to use the word or. If it comes like this, it is possible to write that as just one single inequality. So we've got the set builder notation on this one. Let's go ahead and do interval notation. Remember, we're going to go left to right. So we're going to start way down here since this arrow goes all the way down to -infinity. So we're going to do -infinity. Okay, so we got those brackets, put a comma. It stops at -5. It's not included, so that's going to be a round bracket. and then it's going to start up, so we're going to put a union here. It's going to start up again at 9, so I'm going to put a 9 right there. And again, that one's not included, so this one is going to be all round brackets, goes forever all the way up to positive infinity. And there we go. Now, this last one, we just have to write down a sample solution, a number that would work and make that inequality true or be in those intervals. So I'm going to write down 2 because this comes in 2 different pieces. Pick any negative number you want that's less than -5. So clearly we can see that -8 is shaded. So I'm going to write -8 would be 1. And I'm going to write 12 would be another one. Now, you don't have to write 2. You can just write 1. That's totally fine. I happen to just write 2 on that one. Okay, so that's how you do that. Again, we want to be able to graph these inequalities. We want to be able to write them down in set builder notation, write interval notation. Again, this is the one you really want to focus on because it's so important. It's new, and we use it all the time. And then you also want to know how to write down what some of the answers might be, sample answers, as we've said. Okay, coming back over here, let's take a look at the bottom of this. Go ahead and rate yourself how you feel right now, and then I want to take a look at this thought experiment right here, okay? So, the thought experiment. Positive, negative, and non-negative can be translated into inequalities. So, the word positive means, if we were to graph this, I mean, everybody knows where the positives are. Zeros here, positives here, and negatives are right here. So, positives are on this side. Well, if we wrote that down as an inequality, what we mean is the answers, or the positives, are bigger than 0. So x is greater than 0. That means positive. By the same token, if x is negative, the answers would be down here, so they would be less than 0. So x is less than 0. Now, you may not have heard this phrase before. It's called non-negative. A lot of times we're interested in making sure that things are non-negative. We don't want them to be negative at all. Well, non-negative would mean this. It means it's not negative. So we'd cross off this part over here, and anything from here forward would be okay. So what we'd start with is we'd start with 0 and go this way. So anything that is, and I'm going to write it this way, x is greater than or equal to 0. That would be what non-negative is. So it's got to be 0 or bigger, and that would make sure that it's not negative. Just kind of a point of curiosity. You will see those occasionally, and so it's important to know what that means. If you see x is greater than 0, oh, that just means it's positive. X is less than 0, oh, that just means it's negative. X is greater than or equal to 0, that means it's 0 or bigger, so 0 positive. Another way we describe that is just non-negative. All right, good luck with the assignment.